Welcome to Understanding Gradle. This time, instead of looking at one thing in detail, we'll look at a complete project structure that you can use for larger, maintainable projects that are worked on by a whole team. This structure is keeping goals in mind I already mentioned in the other videos. The first thing is that we put build configuration and build logic into a central place using the convention plugin approach. The second is that we centralize dependency version management. And third, we set up some tooling in the build to keep the dependency setup clean over time and enable all team members to work with the dependency setup and do dependency upgrades. The example project we're going to look at is available on GitHub, so you can clone this and follow along. I won't go into details, and a lot of details are also only examples. You can vary many things and still follow the general idea. Whenever I mention a certain Gradle concept in this video, I'll have a link to the video explaining that concept in detail. This video is also available in multiple variations for different kinds of projects, but the general structure is the same each time. This video shows the example for a classic Java project setup, but you can use the same structure for any kind of project, and especially any kind of JVM project like Kotlin, Scala or Groovy. Let's first have a quick look at the general project folder structure. In this setup, I put many things into the Gradle folder. So then, during development of the project, where the build itself is not changed, you can collapse this folder and it doesn't interfere too much with other concerns in the software development. Then in this example, our software has multiple components in multiple Gradle subprojects. Each of them is located in a folder and has a build Gradle file. The first thing to look in the Gradle folder is the settings folder. This is a small separate Gradle project for defining everything that goes into the settings file. We put it here so we can hide it away a bit and also reuse it in different places. Inside we have a convention plugin for settings. Here we define, for instance, repositories shared in the build and tell Gradle how our project structure is set up, that each subproject is found in a folder with a build Gradle KTS file. It also can apply global settings plugin that add additional analysis functionality to the whole build, like the Gradle Enterprise plugin to always publish build scans. We also specify here where Gradle can find our project convention plugins, which is the next subfolder in the Gradle folder I called plugins here. This is what traditionally would be build source, or also often is called build logic. Before we go there, we have a quick look at the settings in the root, which now only applies the settings plugin. In the plugins folder, I split up our convention plugins in multiple categories by using Gradle subprojects again. The convention plugins build upon each other. At the very bottom, there are the dependency rules plugins. These define component metadata rules to add additional information for external component Gradle needs to know to detect certain conflicts. In essence, everything that's not a dependency definition or a version constraint for a dependency that we still need to get to the right dependency resolution result goes here. So it's neatly tucked away in this place and we don't need to worry about it in our build Gradle KTS files. In this case, I used some existing plugins to add some metadata rules, including some plugins I published myself. Maybe these are useful for you, but if not, you can also check these plugins and get inspired from them to adjust the rules you need. After the dependency rules plugins, there are what I call base plugins. These define basic information for the build that's not very specific to a certain type of project or technology. Things that go in here are, for example, the group and the version of the project. The version in this case I put into a separate version.txt file, also located in the Gradle folder, which is then read in the convention plugins. Here I also enable consistent resolutions for the dependencies and make sure our platform project is known as the place where we define dependency versions, to which we'll get a bit later. We also define some lifecycle tasks for our root project to make the build easily accessible. The next thing of convention plugins are the Java plugins that define everything related to Java compilation, test execution, or other project structuring around Java libraries. Examples you find in here are the Java version to compile against, or the test framework we want to use. Here we find some of the convention plugins I use in the build Gradle KTS file to assign types to projects. you can see that I not only have plain Java libraries, but also Java libraries that get published or Java libraries that have test fixtures. Depending on your project, all Java libraries might also have all the same functionality, and you won't have this distinction between different kinds of Java libraries with certain extra aspects. The next set of plugins are what I call the application plugins. These are just used in one of our sub-projects, the app project. That's the project where the application is assembled in the end. So typically in this place you have more customization. For example, some custom tasks that generate some extra resources, or end-to-end tests that test the application as a whole. So in our app project we use our own application convention plugin. I already mentioned that next to the settings and plugins folders there is a platform folder inside the Gradle folder. In this folder we have a build Gradle KTS file. Here the whole dependency version management is happening. Wherever I have a library that consists of multiple components, I use a BOM to define and align the version. In cases where a BOM is not published, I construct one myself in the component metadata rules. These are located in the dependency rules convention plugin, as I mentioned earlier. For all other components, I define a version constraint directly. Whenever I know that for some reason I can't upgrade a library beyond a certain version, I add an additional version reject constraint. This not only documents this for my colleagues or my future self, it also allows Gradle to give me suggestions about version upgrades, which I'll get to shortly. First, let's take another quick look at a build file where we can see that next to the convention plugin, we only have defined dependencies in API or implementation scope to other components. So all our build configuration and custom logic is nicely put away in the convention plugins. And once it's working well for our project setup, it's probably not touched for weeks or even months. The dependencies, however, are something that's always in motion. While developing the software, you might want to introduce new sub-projects, use other external components, or just use components you already use in other places differently. So a very important thing in my mind is to set up some good process and tooling around that to manage the dependencies and their versions. Otherwise, a nicely structured build can quickly get messy again, because you just have so many possibilities to do things in Gradle that it's easy to miss something. That's why in my mind an important part of a good setup is at least to have some analysis tooling around the dependencies. That's why we have another sub-project in our plugins. In this, we add some build configuration to analyze our dependencies. Gradle doesn't offer much out of the box here. So you have the option to use additional plugins. I'm using the dependency analysis plugin here, which I can recommend to everyone. And alternatively, or on top, write some own analysis code. This is a particularly nice approach because then you can give actionable analysis results that fit your custom project structure. In this example, I added some code to check that there's no version defined in the build Gradle files because we want to keep all the versions central in the platform. The error you get if you do it anyway will tell you exactly what you'll have to change. I also have some code that checks that dependencies are defined in alphabetical order. The dependency analysis plugin is able to check if dependencies are unused or if they are in the wrong API or implementation scope. It allows us to write so-called custom post-processing tasks to give an actionable advice as well. So here we tell exactly what dependencies to remove where and what to add if the scope doesn't fit. And for the platform, we add a small task that checks if new versions of the dependencies we are using are available. The different check tasks can then be integrated in CI pipelines so that you can get notified if you have unused or wrongly scoped dependencies or if there are new versions available. Apart from the things I showed, you can find some more details in the example. Like some of the build Gradle KTS files have some specifics to test setup because they reflect situations you often have in existing projects where, for example, some tests use an older test framework. This was an overview of a larger project setup with Gradle. You may explore the example yourself or watch some of my other videos if you want to know more about a certain detail. If you want to follow along, please subscribe to the channel. You may also follow me on Twitter, where I always give an update if I have something new to share about Gradle. See you next time.